This question from Pathfinder discusses what happens if we have a gas inside a capacitor. Let's discuss. Now the first question they are asking is that whether this equilibrium is stable, unstable or neutral. Let us suppose that the voltage of the battery is some V, the separation between the pistons is X, and the pressure of the gas is some P. Now right now, because there is equilibrium, the attractive force due to the charges must get balanced by the pressure force due to the gas. Now this gas, due to the collision of the molecules, will try to push these pistons away, and hence there is a possibility of an equilibrium. So therefore the force due to the charges must balance the force due to the gas. Now the force due to the charges, F charges, can be written as, now the electric field will be V by X, and therefore the contribution by one plate will be half of that multiplied by the charge on any one of the plates. So that will be K times epsilon naught A by D. So we notice that this force due to the charge is some constant multiplied by 1 by x square. Let's call this as equation number 1. Now if you notice for the gas, that will be P gas multiplied by the area. Now P gas can be written as nRT gas upon the volume multiplied by the area. Now since the pistons are metallic, we can safely assume that T gas remains a constant. Hence this F gas comes out to be some constant multiplied by 1 by x. Now you notice the difference between the two forces. One varies as 1 by x square and the other varies as 1 by x, and at some particular x they must be equal to achieve equilibrium, but at different x there can be a problem. So let us see that with the help of a graph. So here we draw the forces and here we show the x. Now since 1 upon x square will be larger than 1 by x for smaller values, the graph will remain above, something like this, and for larger values of x the graph will remain below. Hence the graph will be somewhat like this. Now this blue graph is for 1 by x and the red graph is for 1 by x square. Now at some particular special point we have equilibrium. Now suppose we move towards right. That means we try to increase the separation between the plates. So if we do that, we notice that the red graph now falls below. That means the attractive forces become less than the pressure forces. Therefore, we can easily conclude that the equilibrium will be unstable. Similarly, we can check it otherwise also if we attempt to change the separation by decreasing x. Now for the B part, now we can easily answer if they are saying that the voltage is slowly increased. Now if the voltage is increased, that means the charge will increase and hence the attraction will increase. So therefore ultimately the plates will try to collapse. So x will ultimately approach 0. I hope this was helpful in some way. Thanks for watching.